Bond J is a 4% coupon bond. Bond K is a 12% coupon bond. Both bonds have an 8% yield to maturity, make semi-annual payments, and have 9 years to maturity. Since the bonds have 9 years to maturity and make semi-annual payments, we'll enter 18 for the number of periods in our financial calculator. If interest rates suddenly rise by 2%, in other words, go from 8% to 10%, what is the percentage price change of these bonds? What if the rates were to suddenly fall by 2% instead, in other words, drop to 6%? What does this problem tell you about the interest rate risk of lower coupon bonds? Let's begin by solving for the current price of both bond J and bond K. For bond J, we have an 8% yield to maturity. Since the bond makes a semi-annual coupon payment, we need to take the yield to maturity, divide it by 2, and enter 4 for the interest rate. The payment on a 4% coupon bond is $40 per year. Since it pays a semi-annual coupon, we'll take the $40 and divide it by 2, enter 20 for the payment. The face value of $1,000 is entered as the future value of the bond, and we can solve for the bond's price. Bond J sells for a discount since its coupon is below the yield to maturity. The price of bond J is $746.81. For bond K, we've got a 12% coupon and an 8% interest rate. We'll take our 8% yield to maturity and again divide it by 2 since the bond pays a semi-annual coupon, and enter 4 for the interest rate. The payment on the bond is our $120 a year coupon divided by 2, enter 60 for the payment. Again, we'll enter $1,000 face value as the future value of the bond, and we can solve for the price of bond K. Bond K has a present value of $1,253.19. It sells for a premium because the 12% coupon is greater than the bond's yield to maturity. When interest rates increase to 10%, the value of both bond J and bond K will decrease. Let's go ahead and consider bond J. The number of periods remains 18. Our interest rates increase to 10%. We will enter 5, which is our 10% yield to maturity divided by 2 for the interest rate. The coupon remains the same at $20 per semi-annual payment, as does the face value. The price of bond J will decrease to $649.31. This is a decrease in value of $97.50, or a 13.1% decrease in the value of bond J. For bond K, we'll keep 18 for the number of periods. Our interest rate again is our 10% yield to maturity divided by 2. The payment on the bond remains constant at 60, as does the face value. We can solve for the price, and we find when the interest rate increases, the price of bond K decreases to $1,116.90. This is a decrease of $136.29 and represents a decrease in value of 10.9%. Let's consider the case when interest rates fall to 6%. In both cases, we'll find an increase in the value of the bond. Again, enter 18 for the number of periods. In this case, we'll enter 3 for the interest rate, which is our 6% yield to maturity divided by 2. The coupon remains the same at $20, as does the face value at $1,000. The price of bond J will increase to $862.46. This represents a change or an increase of $115.65, or a 15.5% increase. For bond K, we will keep 18 for the number of periods. Our interest rate will be 6 divided by 2, or 3. The payment remains constant at 60, as does the face value at $1,000. Bond K will increase in value to $1,412.61. This is an increase of $159.42, or a 12.7% increase. Notice the low coupon bond is more sensitive to changes in interest rates than the high coupon bonds. All else the same, lower coupon bonds pose more interest rate risk than high coupon bonds.